Hello everyone and welcome onto the webinar today. We're going to be looking at how we can use Amazon Web Services, or AWS for short, with the RAD Studio 11, the latest version. My name is Stephen Bourne. I'm going to be hosting today as we go through. And joining us online today, hopefully a little bit later on, will be Marco Canto to help out with the Q&A, who's been driving the birth of this library into the product. And also Richard Hatherwell, who is the lead developer on it. Hi, Richard.
Hi, great to be here.
So, Richard, just for everybody else who doesn't know you, do you want to share a little bit about your background and your kind of your cloud knowledge?
I have been a long-time Delphi developer since the late 90s, since Delphi 2. Since then, I've worked in a lot of different technological platforms. And in the last 10 years, I don't think I've worked on a greenfield project that hasn't been in some way integrated with Amazon Web Services. And that's where I've been working to bring Delphi and Amazon Web Services together.
Cool. So yeah, let's get in. And today's session, we're going to kick off by having a look at some of the background around the cloud, just to get that introduced to people who may not be so familiar with it. We're also going to have a quick look at some of the key services that we're going to be looking to cover within the libraries. And then we've got a demo of the libraries working together with those key services, which Richard will take us through. And then we'll have some Q&A at the end. So let's get in. So I appreciate the kind of the introduction we have here is going to be very high level and very kind of just giving you the kind of the flavor of what cloud is. It's not meant to be a complete explanation of cloud, but hopefully from this you'll kind of get the key drivers for why business and people like Richard have been working with AWS for so long. But the key essence really of cloud computing is about making large scale compute power accessible to anyone. And this is often done through kind of time sharing. There's been stuff that's worked on uh, from many years. IBM originally had stuff for you put your job up into a queue and it would process on the machine when there was availability to do it on premise, moving right the way through to the kind of the modern capabilities that we have with these hosted data centers. The key essence of them is all about making compute power available and getting it shared around as possible. One of the key drivers for this has been and always will be about cost cutting. It's about helping focus the core business on doing the jobs of business rather than focusing it on the obstacles that gets thrown in by IT infrastructure having to be managed and ordered and configured and kept up to date and all the other kind of bits that go around with that. So really kind of say this is all about making sure that you can get access to the types of things that you need to build modern architectures very quickly, without having to have the full scale capabilities required to manage and keeping that skill set up to date as well to manage all this infrastructure. So now we've got the essence of cloud computing, let's look at the why. One of the key things in terms of the essence was about the sharing, the load balancing of workload across equipment. Now, with cloud computing, these data centers are vast, huge amounts of computing power available to access into, which means that you can get on demand what you need. Now, with on-premise, if you wanted to have on demand some hardware for a specific project, or you needed to say get a lot of work done very quickly on some batch processing, you need a lot of computing power for it. The cost of having that on site or having it on standby at site for when you need it can be quite a lot. You've got the cost of the equipment, you've got to guess how much space you need. So that again, you could be over buying what you need, and you've got the ongoing cost of having all that space. or you can just rent it for the period that you need it in the cloud, and spin down as you need. It's very flexible to expand or reduce what you're using, without having the ongoing upfront cost or the ongoing maintenance of it. And that's really kind of a big beneficial factor here for development, that you can get an idea and you can spin up an instance, or spin up the services that you need to do what you need, get those capabilities very, very quickly without having all the time, effort, and issues around configuring, setting up, and getting that going. And not to mention kind of the learning curve that goes with getting some of those things set up. So having that pre-tested functionality is a great cost saver, time saver as well. But also one of the key factors around the cloud is security. If you look at storage and management of data off-site, we've seen things like Blue Cross Blue Shield who've had a data breach in the past, and they had hardware, hard drives physically in a locked server cabinet, and having those, they had a break-in and the stuff was stolen. It ended up costing them $1.5 million in fines because the data wasn't encrypted at rest. Now, having those kind of headaches taken away by having it hosted in the cloud, is tremendous. That is a real saver, and there's best of practice security elements built in because they're feeding out to organizations of all types around the world. So it's great to be able to tap into that kind of experience. But also one of the key things is around data loss and management there. If you think, a business, if they lose their data in their entirety, will probably go out of business within under 18 months. That's what we've seen over time. Testing your backups, checking they're working, making sure that if anything happens from a hardware failure, that you've got resilience and keep going. That takes a lot of time, effort, and money. And also, a reliance on people to do things. With the cloud, that kind of is all taken care of for you, which means you're a lot less likely to lose any data. And also, in terms of the maintenance of all the hardware and and everything, yes, there's a little bit to learn for getting to the cloud, but it's a lot less than the time and the effort that it's going to take and the cost of managing those skills on premise. So we touched a little bit on the kind of different setup and why you'd want to look at the cloud, but introducing little bit around the cloud, some terms that you might come across. Certainly, the first three terms are private, public, and hybrid cloud. Now, a public cloud is something that is freely accessible to anybody. It's in the public domain. And that's kind of used for services where you might want to kind of put a request in and get back a response about what the weather's going to be like, for example. Private clouds, this is where you want to have some of the services that are available in the cloud, but only privately available to your organization. And then a hybrid cloud approach looks at being able to provide a mix between the two. And things that we're seeing nowadays as well is having actual the cloud running on premise with the services running as part of this public-private hybrid approach, where you have certain bits that are running kind of locally. And then elements that are running offline. And certainly the hybrid cloud approach is something that we're going to be seeing more of, specifically with new technology trends coming through in the future, things like 5G, on the mobile side of things with the data connectivity there. We're seeing there's a big push in terms of making the hybrid cloud more accessible and available. And part of that is down to doing with kind of things like the laws of physics, making sure that you've got the smallest distance for the data to transfer, especially if you're kind of looking at things like some of the great use cases coming forward, like remote surgery, for example. Having the tactile feedback on the controls that the surgeon's using, that needs to have something that is close and nearby, because you can't bend laws of physics. Light can only go so fast, and to get the tactile feedback, it needs to be instantaneous. So there's some interesting kind of stuff around those, and the hybrid cloud is going to be something we certainly hear a lot more of. But in terms of the deployment, we've spoken about the kind of the hardware and some of the cost bits. Here, the infographic at the bottom here just kind of gives you a bit of an idea between some of the different terms. Obviously, on-premise, you're managing pretty much everything. But if you start looking at the cloud service elements, you've got the IaaS, the infrastructure as a service, which is really where you manage the applications, the data, the runtimes, the middleware, the OS that's being deployed out. So so like the EC2 instances on Amazon would be a good example of that. And then you have things like the platform as a service, where you are managing the application, the data, and the runtime. And then full software as a service, which is where you just buy the software and it's managed completely by somebody else. You just log in and use it. So as developers, we're quite keenly looking at the platform as a service, the infrastructure as a service areas, and it may well be that we're putting together and bringing to market software as a service that we're sharing out. Um, but hopefully that kind of gives you a good overview and intro to these areas. So what is the Amazon Web Services? As this is kind of the key topic area for today, I think we kind of draw the conversation directly back in towards Amazon. And ultimately, Amazon are the leader in the market at the moment. It's the world's most comprehensive and broadly adopted cloud platform. They've been running out their services since around about I think it was March 2006. The simple storage service S3 was introduced, and then I think the EC2 Elastic Cloud Compute platform was released in August 2006. So they've been around for about 15 years now. And these products pioneered the usage of server virtualization, infrastructure as a service, and then getting on for the platform as a service offerings that came through. And what it does is provides basically these on-demand cloud computing platform APIs. One of the things that's quite revolutionary about the way Amazon brought the stuff to market was the way that it's all built. It's metered on a pay-as-you-go basis for the kind of the hardware, the operating systems, the software, the network features. There's a full stack of things that you can implement and use to set up your data center literally in the cloud with all these different elements introduced through. And what's quite nice about Amazon is they have server farms around the world. So depending on the different geos that you're based in, depending on the legal requirements, they have server farms in the UK, in America, a number of different places around the world. And you can just pick up and choose whichever one you need for the project that you're deploying out against. Okay. So I'd like to now get on to introducing the key Amazon Web Services that we're going to be talking about. So the first one we've mentioned briefly already is just the S3 storage. Now this has a very, very high reliability, and this is kind of critical for applications that are needing to follow certain certifications around data security and so on. So it's a very, very quick way to be able to get data moving. The S3 storage itself is there to help kind of reduce the cost without upfront investment of the hardware. You literally use what you need and pay for what you're using. And being tiered, there's a free band, and then beyond that, then there's a paid amount to use, depending on how much you're putting up there. Some of the things that we've mentioned already about data security, obviously they've got full compliance around that, audit capabilities as well for managing who's putting data in, taking it out, who's accessing it, and so on. So again, a full stack of capabilities and management options to apply to pretty much any kind of business scenario. And I say it's very, very easy to manage at scale and to robustly push the data out. And it's also got things like replication tools built in, and a set of other services configured into it as well. So as data is put in, you can then trigger different events to happen. That might be to move the data from one region to another. It might be to kind of trigger notification services, or to trigger a queue that there's data that's been arrived in. So quite a different set of different things that you can do. Now, one thing that's actually quite interesting from the time that I spent at Nokia, there they were using the S3 storage a lot with artificial intelligence, being able to push data up into it and then process the data directly from it. They found it was actually really, really fast for data processing, which why you can see how things like machine learning. There's a lot of use cases now that are using S3 for the data collection and pushing it up there ready for the queues to then process it and then sort it out into the models that need to be used. So, Richard, anything to add on the S3 storage element from your side?
I think you've covered it off really well there. I mean, it's worth pointing out that I mean, some of the limits don't really seem like limits as well. Like you can store 5 terabytes in a single data object. There's not many people who need 5 terabytes in a single file or more. So even though it is a web storage API, it is designed for huge scale. Yeah,
Yeah,
it's a
that's
great service.
cool. I think that's quite an interesting thing there to mention, which I'm sure you'll come back to in your demo a little bit later on. You can store things up to 5 terabytes in there, but who would want to rely on a data connection being able to push a single file up at 5 terabytes in a single shot? You know, the ability to be able to split that up and to push it up using things like uh, different data chunks and then have it all kind of merged together to make sure it safely gets delivered
And Amazon
is
don't, they actually encourage you to do that because their
yeah,
API doesn't allow you to send data in a single shot of that size, but they provide APIs to send up parts of objects up to 5 gigabytes per part. Um, but I'll talk more about that shortly.
yeah, cool. So that's the S3 storage. Another one that we're going to introduce through is the simple notification service. And you'll notice the URL for these are up on the top of the screen there. And also, if you go to those URLs, there's a link there to be able to sign up to kind of get access into the basic subscriptions or even move on beyond that. So if you want to have a play with those later on, then definitely keep an eye out for those links. But Simple Notification Service is a fully managed messaging service for communication between application to application or even application to person. So it can be used from to kind of push notifications out to you, but also to send messages between applications to allow them to know that something's happened. Um, Now, there's three different models that they use for sending messages. There's the publish subscriber one, which is what we've got kind of an image of at the bottom here. There's also an SMS, and then there's also the mobile push. So each of those is available under the SNS APIs. But what's quite interesting about using the simple notification service is as you publish the message in and it's then received into the SNS processing engine, you're able to set up a number of different topics. Um, Now, what you can do there, you can then actually filter out messages that are relevant or not relevant um, to then forward on. So it very much allows you to define out what you want to know about and what you don't want to know about. So that means that straight away, as a developer, you can say, right, I'm really interested in things that are relating to, I don't know, say this was a pet shop or something specifically relating to cats. So when stuff comes through about dogs, you don't send it on to the cat person, but then when the dog stuff comes through, so on. So you can manage the bits around like that, which is quite cool. And then you can put policies in place to help manage the subscription element. And then you can have a number of different subscribers that are working through on that, and that can be then going out into kind of a queue. It can be going out to Lambda expressions. It can be being pushed off to a HTTPS, on a kind of a webhook callback or something. It can be triggering an email to go out. There's lots of different things that you can do around the SNS side. And the quite interesting thing here is the free tier offers 1 million requests free. So that's quite a sizable chunk to have free to run with, which is pretty cool. And so it's very deeply integrated with the Amazon Web Services. Richard, anything else to add on here?
Yeah, I was going to say, and I will talk about this more in detail when we get to the demo. But the idea of fan out, it's the architectural pattern you want to use when you want to do lots of things very quickly on something happening. So on an event, you send a message, and then you don't have to worry about the scale, because many things could be subscribing in to this, and then they can work within their own context. So you can gain scale very quickly by having lots of parallel tasks triggered off of an SNS. So it can be a very powerful service.
Okay, so the last one that we want to have a look at is the Simple Queue service, the SQS. Now, Amazon Simple Queue service is a fully managed queue service that enables you to decouple and scale microservices, distributed systems, and serverless applications. SQS eliminates some of the complexities and the overheads associated with managing and operating messaging queues around middleware, empowering developers to focus on differentiating their work. So one of the things that what you can do with kind of the Simple Queue service is to send, store, and receive messages between software components. You can do this at quite a large volume, and this is one of the things that is quite powerful around the SDK. But it also has kind of a lot of use through command line through the SDK. So, Richard, I think one of the key things people struggle with sometimes is getting their heads around the use of SQS. So, do you want to just kind of give us a quick example of how it makes sense and when to use it?
Yeah, sure. So we've got so anytime you need to line up a series of work to be done, you can use a queue. So a queue is just messages ready to be processed. So you can send messages to that queue, and then you can have another process receiving messages, listening to that queue. The message on the queue, or in SQS terms, it's restricted to 256 kilobytes. So it's not designed to be large amounts of data, but it's supposed to be a message that instructs another process to do something. And as you've put down here, there are a couple of different types of queues which help for slightly different scenarios. So you've got the standard queues, which are designed for very high scale, maximum throughput. And then you've got the FIFO queues. So standard queues only, they will deliver a message at least once. And while they are best effort ordering, as this says, they aren't guaranteed to be definitely delivered in the order they were received. SQS FIFO queues are guaranteed to be delivered in the right order, and the message will only be delivered once, which means you have to design your processes appropriately for which purpose. Most of the time, I use standard queues. Most of the time, I think most people use standard queues. FIFO queues are really important for when it is critical that your application does things in the correct order and likely cannot deal with multiple deliveries. So, say for example, if you've got a process where if you're controlling a process with a queue where it triggers something, you're integrating with a remote API or a remote service where things have to happen in a very specific order, a FIFO queue is likely what you want.
Okay, great. So FIFO, obviously, they're first in, first out for anybody who's kind of missed that one. Brilliant.
Yeah, sorry.
That's right. No. Okay, let's move on. I hope that's been a useful introduction to a few of the different services. So we've had a quick look at the S3 storage, the buckets, and being able to put the data up there, and the high security around that. The simple notification service, which allows you to filter out and push the messages around, and then the SQS, the simple queue service, which is they're going to be where the data kind of goes into. So what I want to do now is just introduce you to the Appercept AWS SDK for Delphi, and this very much is our first introduction of this SDK, which Rich has been developing and working for. It has got direct mappings to the Amazon Web Service APIs. We've started off with a number of the core APIs like the S3 storage, the simple notification services, and the queue. And this has kind of got the basic access permissions and everything added onto there. Now, I think that's really nice about the library is it's built based on modern architecture. It's using parallel libraries, the HTTP client library, to ensure that we've got the HTTPS is fully managed and everything else like that. It's using kind of the APIs with JSON communication. There's elements of asynchronous method calls running in here, and also anonymous methods as well. So all these modern bits together mean it's very, very easy to read and understand. So very, very simple to integrate into your existing applications. There's also some pretty extensive documentation and demos which are available to take you through. So, Richard, I'm going to hand over to you and let you have a quick start at explaining a couple of the core bits here, and then we'll get into the demo that we're going to be running.
Okay, so so there's 3 examples here. We'll start with the simplest of these here. So the simple storage service, the S3 example on the left there. As with all the service implementations in the Appercept AWS SDK for Delphi, which I am also super excited to be demoing to you now. It's been a while in the making. We have a unit that you need to require. So the unit is AWS.S3 for the simple storage service. And we have a interface to a client. So we define here a variable S3 client is an IS3 client. So we're going to construct that client, which is the implementation is a TS3 client. And then we ask the S3 client to list the buckets, and we're going to store that in a response variable. And then within that response variable, the response for a list buckets request will have a list of bucket names within it. So this example here just iterates over the response buckets, and we'll write them out to the console in this example here. So that's a very quick, clean, simple. That is valid code that would work. It's while it looks like pseudocode, it's that would compile and run on with the AWS SDK. If we move on to the SNS example, this is a slightly more complicated example, just to demonstrate that. Okay, so we've got the AWS SNS unit here to bring in the simple notification service. We have an SNS client variable that is an ISNS client. You can probably see the pattern emerging here already. The difference here is I've defined a request object, which is an ISNS publish request, and I'm creating that request object to be a TSNS publish to phone number request. And within that, there's 2 required arguments. There's a telephone number to send a text message to, and there is a string for a message to send to that telephone number. The next line is again, it's very similar to the S3 example. We're asking the client to publish a message with its publish method, and we are passing it the request that we want to pass in. So we actually, because this is a slightly more complex request, there's more data going into it. So anytime we need to add in request data, we create a request object, and each request object is specific to the request that we are making here. And then we say if the response is successful, we know that it was sent to the relevant, or it was accepted to be sent to the relevant mobile number, and we can do something based on whether the response was successful or not. The SQS example is almost identical, but it just demonstrates we've got here again, we bring in the users, we use the unit, the AWS SQS unit, to refer to the simple queue service. We define a client, SQS client, which is an ISQS client, and we instantiate an SQS client from the TSQS client class. We then ask the client to send a message, and send message, even though it can accept a request object, like we do on the pattern in the SNS example, because it's a common thing just to send a message directly to a queue. There is an overload here which says send message to this queue URL with this content, message ... And then again, we say if the response is successful, the response, we can then make a decision based on whether we actually were able to send that message. There are within the API, within the SDK, there is automatic retrying. There are notes here on error handling. There's no error handling shown in these simple examples, but exceptions will be raised on certain scenarios, and they would need to be potentially handled. Most exceptions are retryable, and the SDK automatically catches and retries those errors until a limit is hit on its retry. So if, for example, that say if for any of these examples, if like list buckets, if it was, for example, not able to make the network connection for a couple of attempts, but able to do it on the third attempt, you don't need to worry about the retries. The SDK has done that for you without any changes to your code.
Okay, cool. Now, the one thing I'd probably just ask here is, you've got the objects being created, but nowhere is it saying where they're pointing to. So just explain a little bit about how that works.
So this is showing the simplest scenario, which is, say, let's focus on the S3 example as a clean, simple example. When you instantiate the S3 client, it will resolve configuration based upon Amazon's standard configuration. So Amazon's own SDKs define some locations where there are ini files, which will store your some basic configuration, like what region you want to operate in, and also credentials that you want to use to make the requests. So obviously it's a bad idea to bake any credentials into your code, because you might accidentally go sharing your credentials in a repository if you accidentally check that in. And of course, your credentials are likely to be different at different stages of your application's lifecycle. So you're likely to use different credentials for test and development than you are in a production environment. So you need a way to define what those credentials are, so you can do that in configuration rather than baking that into your actual application. So it will automatically resolve out of the environment. This is all documented in the help within the SDK, by the way. It will resolve the environment variables that Amazon's own SDKs will honor, and also, as I say, the ini files, as long as they're located in the correct location, the same location as Amazon's configuration. And you can always override those. So if there's a reason why you need to specifically set credentials or a region, you can do that. And within the configuration as well, Amazon's own configuration is profiled. So you could have multiple different profiles for different applications configured on the same machine. And you could actually say this application should load profile for this application. And it will resolve credentials and regions and so on based on that. So the other thing as well is once you deploy to actual Amazon resources like an EC2 server or to an ECS cluster as a Docker instance, Amazon have a set of metadata services designed to actually hand out temporary credentials for you, and the Appercept AWS SDK will automatically resolve those credentials for you, and will automatically assume any roles and give you the relevant access, just like a standard Amazon SDK would.
That's cool. That's a really clear explanation of it. Thank you. Okay, so we've had quite a bit about the different services. We've had a quick introduction to what they're for. We've had a quick view here of how we can actually code to use them. So it's now time to kind of actually have a look at those in action. So Richard, do you want to just take us through the field example here quickly and then give us a show?
Yeah, sure. So I've created a small field report demo, and the idea is that we've got an end user somewhere out in the field with a smartphone app, and it's capturing some data. In this case, it's going to allow the user to take a photo, add a small bit of metadata to that photo, upload it to an S3 bucket. That S3 bucket is configured to trigger notifications to SNS. Now, as I said earlier, we could have skipped the SNS here and gone straight to a queue, but SNS is a great way, and this is a simple example here, where SNS could be used to allow a lot more integrations to happen. But in this example here, we've got one queue that is subscribed to the SNS topic, and then we've got an application, the review app, which is a desktop application that will show you a message that comes in, let you review the content and decide whether you want to discard or archive that item of data. So shall we?
Yeah, I'll make you the presenter here. Okay.
So over on the left here, we've got the field report app running on an iPhone. In the middle here, we have got the review field reports app, which is a standard desktop application. And down the bottom here, we have got an archive process running. which is just waiting to archive reports once the review app has decided whether we're going to archive or discard the field reports as they come in. Over on the right here, to show you what's going on behind the scenes, we have got the field report inbound reports bucket, which is currently empty, as you can see, and we have another bucket on this tab, which is the field report archive reports bucket, which, as you can see again, is empty. Let's set the scene. So I collect vintage computers, and I'd like to create an inventory of my stock items. So I'm going to use the field report app to collect that and review my inventory. So if I take the field report app now, and we can see there I've got a Silicon Graphics Indie, so I can use that, and I'm going to say SGI Indie, say done, and I'm going to hit the save button, and that uploads to S3. So S3 is configured to trigger notifications on SNS, as we saw before, and SNS will then notify any subscribers to that topic, and we have one queue at the minute subscribed to that topic, which is the new report queue. So in a moment, once that notification has worked its way through the system, the review field reports app here will receive that, and we can see that it's started counting down, because this is indicating to us the time remaining on the message visibility timeout. So once this gets to 0, it's going to discard this from, or it's going to remove this from our visibility, and it's going to go back to the queue, and then we just ask for the next one off of the queue. So we've got the same image back because it's the only one in the queue at the moment. And we can say, okay, yeah, that's great. Let's archive that. Well, in fact, let's quickly look. This is in our field report inbound reports. There's still nothing in our archive, but here, oh well, yep. So there we go. So that has come back again, demonstrating that it's going to sit in that queue until someone deals with it. I'm going to hit archive now, and you can see almost straight away the archive process picked that up and says it's done. So if we go and look and refresh the archive reports bucket, we can now see that is sitting here in the archive report. The metadata that was attached to the report is actually a tag. On Amazon Web Services you can add tags to items, and we can see here I have a tag called notes with the value of SGI Indie attached to it. We can now submit a couple more reports just to demonstrate it slightly further. We have an SGI dat drive, an SGI hard drive, an SGI O2. So as we can see, we've now got a new report sitting on the review app. It's come in with the notes as before, but I've made a decision that I'm not going to I'm not going to keep small peripherals, so I'm just going to discard this one, and we straight away we get another peripheral. I'm going to discard that, and then we've got here the Silicon Graphics 02, so I'm going to hit archive on that. So again, we see that came through the archive report, and if I refresh that, that is in the archive reports. So let's have a look at some of the code behind this, what's going on. So this is the field report app, and if I take you to the code, we use a standard take photo action provided in Delphi, and once we have that, we give the opportunity to input some text, and once someone hits the save report button, we create a report item frame, and we hand it the data, and eventually once we've told it to upload that report, we then discard the report. So if we have a quick look at what if we have a quick look at the what the reporting the actual item looks like. So here's the frame. As you can see, this is what goes into the list, with the progress bar along the bottom of it. So if we go here to the upload report procedure, so we're taking in the bitmap picture and a report, which is the notes to attach to it. So the key thing here is we're creating some options for the S3 client. We are creating an S3 client with those options, which we're calling LS3, and we are creating a put object request, a TS3 put object request, and we are attaching some data to that. We are saying that the content type is image PNG because it's it's going to be a ping file from the captured image, and we are adding a tag of notes which has the contents of the report, and then so we can get some feedback about the progress, we attach an onSend data callback, which will allow us to update the user interface. And because we're running this in a background thread, so we don't block the main user interface, we have to queue these UI changes back onto the main thread. And once we've defined all of that, we just tell it to actually execute the put object request with the contents of that request. So that is all the front end, the field report app does. Let's have a quick look at the review app. So the review app has an image, and it has a discard and an archive action, and we of course have the notes down the bottom here. We have a countdown timer which just counts down the label for us when it's got a message, and we'll have a quick look at the source code here, which is so in the form show we set up a poller. So this is one of the convenience classes that we provide in the SDK. So this saves you having to directly call the Amazon APIs. We take care of a lot of the details of what goes on polling a queue with this poller class. We specify how many number of messages we want to receive in a batch, or the maximum number that we receive in a batch. And because we don't want it to automatically delete these messages for us, because a user might choose to do nothing with a report, we skip delete. So that means that the poller, its default behavior would be, once you get to the end of a poll cycle, it would delete the messages. But in this case, we don't want to. We define an on before request. So this is a little callback that happens before each polling request. And we're just doing a few things here to work with the user interface. We're making sure, for example, that the user interface is actually ready for receiving the next item. And also, if someone's tried to close the form, we tell it to stop the polling before the next iteration. And then we background task the actual execution of the polling, so we don't block the main thread again. And here we synchronize back to the main thread with a current message once we have a message. And then setting the current message will actually go through. If we have a look here at the set current message, we can see it actually goes through and it decodes the contents of the message, because that will be a JSON payload that gets delivered from SNS. And then we enable the actions archive and discard. If we clear the current message, of course, we disable everything and clear all of the values. Once we so the last thing we do once we have a message is we load it from the values that we pulled out of the message that was delivered to us. So if we go to the load image from, this again, we decode the URL that was delivered to us. We create an S3 client for the relevant region, and we perform a get object, and then from the response of the get object, we load the bitmap from the body. We make a get object tagging request, which will load the notes off of the tags. So here we just fetch the notes value from the tags, and then we the actions. So if we have a look here at the discard action, all we're saying is the SQS client, which is a property of the form, it gets a call to say delete the message from the new report queue, and we hand it the current message receipt handle. And then we say next message, and next message uses a T event to signal to the background polling thread that we're ready to receive the next message. And on the archive execute, we create a JSON object and we send the message to the archive queue on SQS, and then once that is successful, we delete the message from the new report queue, and then again we signal that we're ready for the next message. So if we have a quick look at the archive app, this is the simplest app, because it's effectively it's a background service to be run on a server somewhere. So it doesn't need to be asynchronous. But what we do here is we set up some common options. So while we've seen that you have TSQS options and TS3 options, we have a common set of Amazon Web Service options that the other objects can the other options can inherit from or can clone. So we're creating some common options here with our configuration for our access keys and regions. And then we create some SQS options based on those core options. We are creating an SQS client. We are creating a queue poller again to poll the archive queue with the SQS client. And again, we are polling that queue. And every time we receive a message or a batch of messages, we are iterating through those messages, and we just say process archive request. So if we go to the process archive request, we are decoding the JSON object that was attached or that was posted onto that queue. And as we posted it from the review app, it should have a key in it, and that key should be the key of a report to archive. And we call archive report, and in archive report we create an S3 client based on, as you can see here, the common options that we built at the start. We create an S3 client, and we construct a request to make, which is a copy object request, saying we want to copy the key for the object of a key of a report key to the archive report folder, the archive report bucket, and then we actually perform that copy object request. If it's successful, we output done. Otherwise, if there was an error, it would be caught here. So any S3 exceptions would be caught, and we would log those out to the console. And that is it. So that demonstrates a distributed architecture, multiple applications and services being loosely coupled via cloud messages.
Yeah, thank you, Richard. That was a really informative demo, having a look at the different bits and seeing really in depth about how to kind of manage, and some good examples of good practice to code those in. So in terms of getting hold of the Appercept AWS SDK for Delphi, it's going to be made available through Get It very soon. It's available for the Delphi language because some of the language features that are being used in there, it's for Delphi only. The availability of it is going to be for customers who are using Enterprise and Architect editions, and who have an active update subscription. So if you are on another version where your update subscription is expired, then please feel free just to let us know, and we can certainly help you towards getting live and current, so you can get access into these great libraries as well. And so, following the example that we've used for FMX Linux, it's going to be available through Get It in the coming days. So a little quick safe harbor. Obviously, we want to talk a little bit about going into the future. Anything on this slide that we're going to be sharing here is not committed or confirmed until it's been shipped and released. This is here very much for us to be able to share and get your feedback in terms of what you're after, but also to give you an indication of the direction that we're looking to move forward with the ongoing relationship that we have with this SDK. So moving into the future, we are looking at additional services coming in. One of the ones that is high up the queue at the moment is the simple email service, SES, which allows you to get emails sent through. But also having a look for the future at things like Cognito, which is the identity service from AWS, which helps with single sign-on and credential management. And there's also some thoughts around looking at demand around converting the libraries into a set of RAD components and encapsulating some of the libraries to make them a little bit more RAD to use rather than yeah, everything coded behind the scenes. So really, we're after your feedback, what your priorities are, if you're using AWS already, any specific services that you're looking to use and consume, and that'd be great to kind of have fed back in. So that's pretty much us for today. But before we finish off, I just want to share with you an upgrade offer that we have. If you want to get access into this Appercept AWS SDK for Delphi, you need to be on the Enterprise Architect Edition. If you're buying a new license, then we've got a 20% off offer for Enterprise and Architect Edition at the moment. If you currently have an existing license on maintenance, then please feel free to talk to the sales team. They've got a mechanism to help provide you some credit for your existing license maintenance and help you get upgraded to the Enterprise Edition at a vastly reduced rate. So definitely worth touching out to them and taking advantage of that offer. So with that, let me just thank Richard again for the great demo and open the lines up for some Q&A. Okay, I can see a lot of questions beginning to pile in here. So hopefully, Richard, you can hear me in the background. Can you hear me okay?
Yeah, I can hear you. I'm just having a scan down the questions.
Okay. Great, let's start from the questions up here. Oh, yeah, sorry, just scanning past the ones that we've answered. Yeah, the webinar has been recorded and we'll make the link available up onto YouTube at some point soon. There's a couple of questions around how things are charged for and billed for. And obviously, primarily you need to direct those questions towards Amazon themselves. So we're not in charge of their billing or what they're going to do and change over time. But there's a question here specifically, which I don't know if you know the answer to. Are there any additional charges for file transaction, such as accessing, modifying, deleting, and so on? Yeah, what's the kind of the basic understanding of how that works?
So yeah, Amazon, all of their pricing, and this is a common thing I hear, it's hard to understand often because there's no massive, like, shocking price tags attached to anything, but everything is charged in a very tiny, constant transactional manner. So you do end up paying things like for data transfer ins and outs across different areas. To be honest, it's too complicated for me to go into right now, but there's lots of detail on Amazon's S3 pricing page, which I have posted a link to.
Okay, super. And are there any specific ways you can help control maximum costs? Can you put kind of a cap limit on to
yeah, they provide a number of mechanisms to allow you to set budgets and get notifications about your cost usage. So you would typically get notified at 50% your allowance usage, I think, and then again once you've hit your allowance or your budget. Off the top of my head, I don't think it actually shoots, or by default it doesn't stop your activity at that point, but it will send you notifications to help you look at keep your pricing down, keep your costs down.
Okay. Mm-hmm. There's a question about one of the notification services here, where you're sending out, you have the ability to send text messages. How does that work and how does that get billed? And yeah, specifically the question is how you push the telephone number formatting around.
Sorry, the question about its billing or its telephone number formatting. I'll answer the telephone number
well, I think
formatting
there's
is
two bits.
easy.
Yeah, go on. Let's start with that bit.
So the telephone number formatting, they expect telephone numbers to be in the E164 international telephone format. So you would need to, if you're making a request to send a message, you would need to make sure it was prefixed with a plus country code, and then the rest of the number. In terms of pricing, again, it's a complicated business, and there's a whole section on Amazon's site dedicated to pricing of SMS in particular. But obviously, that's not the only cost. When with SNS, there are other costs around that service. But I think the initial, like, they charge in like blocks of 1 million requests or something like that. So which is very cheap for publishing to a normal topic. That is, for SMS messages, you pay by the message. So.
Okay, cool. And there's a question here you answered from Jens, just about do you just get the JSON response back from the objects? And no, you're doing quite a bit there to pass the different types of data that get sent back into usable objects that you can then work directly within code, aren't you?
Yeah, there are some internal conveniences I use, but I do keep it quite So sometimes there's actually quite a bit of hidden logic in the responses that come back from Amazon.
So just a couple of duplicate questions. Yeah, so there was a question about here in terms of the SDK, anything that you're doing on the services from Amazon. So the SDK is about accessing into the service. Whatever you do when you get there, you have to pay for from your own credentials, and in terms of there's good free tiers on most services to allow you to test and develop on, and then moving into the kind of the paid elements. But anything that you consume is your responsibility. We're just giving you the kind of the pass to get in and to be able to work with it quickly and easily. So this question here is AWS Secrets Manager supported?
Not at this time. It is definitely on my list of services that I'm interested in.
So one of the things with getting this the preview of this library out now is about being able to get from you guys specifically the bits that you want to see next in here. There is hundreds of services now on AWS, and prioritizing where to go first is really what we're after getting from you guys. So if there's specific elements that you're keenly interested in, please make sure that you're kind of flagging something that in the question. We are going to be going through the question log as part of the review afterwards. So please make sure you're getting those bits in. A question here about the type of applications you're using within the demo. They're all FireMonkey applications, because you're running those out onto the Mac. They can all, equally be used within VCL applications. There was a question here about a web application, if you could use it there. I guess if you kind of got full access to the language on the back end, then you could build server-side processing that's doing things to consume the objects, so there shouldn't be any problem with doing that. Will the library, when available via Getit, contain the full source code?
Yes.
Yeah. And the source code, so saying earlier, the source code's kind of well documented through as well, to make it easy to work with. question here about, are we planning to get all the services in AWS covered in Delphi? So there's an awful lot there. This is very much the start, but we're certainly looking to get a deep coverage. Okay, I'm just gonna, Marco's just messaged me to say that he's in, so I'm just gonna make him an organizer quickly.
Sorry, I see the question about the hand passing the JSON that was coming out there. I understand that now. He's saying that we were passing the JSON that came through the notification, and we shouldn't be doing that. If you're, but the actual responses from the API are all taken care of for you. So the representations of JSON and XML, that's all taken care of for you. That is a particular pattern with that service where the message payload could be any value. It could be just a plain string. It could be base 64 encoded binary. But in this particular case, it just so happens that for this demo, I conveniently just encoded some JSON and pushed the string onto the queue and then decoded that later. How you want to deal with that in your application, you're welcome to choose your own methods for dealing with those for encoding your message.
There's a question here about visual components. I'm guessing you mean kind of the, well, maybe non-visual components that you can just put down and then put the property values on. I know that's something that is being looked at depending on demand and specific areas that people want to kind of use. I think we'll probably find certain encapsulations of key things will be something that is certainly being evaluated and looked at for the future. A couple of questions around Azure and Azure support. Obviously, this library is focused primarily about AWS, and there are a few Azure examples out there. I posted one in the chat earlier for some the cognitive services that are listed on Azure that you can go and get from Get It as well. Sorry, not from Get It, from GitHub. So there are other library parts, but this one is just specifically looking at AWS, which is kind of the largest one out there at the moment. A couple of people saying great session, thanks very much.
I wanted to take a couple of the answers towards the end.
Mm-hmm. Yeah, please do.
In terms of release, we are looking for, we're trying to get it on Get It today. There was still one minor issue last time I checked, and I've been out last 2 hours, so hopefully it's ready and will be published shortly. Worst case scenario will be there tomorrow, so it is there to go. The other question I wanted to answer was you already had web services, Amazon Web Services in Delphi, true. We have had support for, I think, 3 services, S3 and tables and probably some of the messaging services. But that support was built 6-7 years ago, was not updated. So the S3 APIs available are really a small fraction compared to what is there. And also it was based on a fairly old infrastructure. It's using SOAP and XML parsing rather than REST and JSON. And also it is the interfaces that are used and so forth are kind of an old school design type of thing. Also, it doesn't really use any parallel programming or way to inject an event handler. It was really more like serialized type of code, which doesn't fit well into like web-based technologies. And so rather than going ahead and like rebuilding and expanding what we have, once we started chatting with Richard, we thought, hey, this is so much better in terms of architecture, approach, and of course the plan is to extend it way past like the few services that we used to have. He has slightly different ones right now, but the plan is getting much broader and deeper. So meaning have the full like API for a service, not just a handful of things. So I wanted to clarify that.
Yeah, I do. Yeah, when I release a service, I do intend it to be a complete API. There's sometimes it's a little bit challenging because Amazon do frequently release updates, less so to some of their more established services, but even on S3, since the S3 client was completed at the beginning of this year, there's been a few tweaks to the API that I've had to add along the way, and there will, I'm sure, be more updates coming for that. There's a question here about, I mentioned temporary credentials. Is there an example provided of using temporary credentials? I have some sample applications that I will make sure some of them are available on GitHub. I mean, temporary credentials are automatically dealt with within the SDK as well. So if you are deploying to an EC2 instance, for example, and you've got an instance role configured on that, the metadata service that Amazon provide on those instances will provide a configuration for credentials to use by applications running on that server. So if you use best practice for deployment, you're not setting credentials anywhere in your code, and you're setting a role, and your application should just get access to what it needs from that role. The temporary credential is automatically resolved for you. I'm sure I can provide more examples of using temporary credentials as well, if people are interested in that. There are a few, sort of more niche use cases where you might want to generate temporary credentials. Like, for example, you might want to have an application that is actually a credential broker that will automatically get a set of credentials on request for a downstream application.
Okay, I think we've pretty much got through the bulk of the kind of the main questions that have shot through. So we'll be going through and having a look at the feedback from this session. I'll just put a quick reply there to Paul with some of the bits as well. So if you've got any other questions or feedback or specific things that you're looking forward to, then please feel free just to primarily drop Marco an email, marco.cantor@embarcadero.com, or even through to me, stephen.ball@embarcadero.com. More than happy to kind of hear what you're looking for. We love hearing about the kind of use cases that you have and what you're kind of trying to develop and push forward for, and what you're looking for the future. There's been some really interesting kind of messages back already. People looking forward to getting going with this, looking forward to trying out some of the different bits, really getting a feel for the understanding around this. But also, if there's specific knowledge areas that you'd like us to dive into further around any of the APIs that are covered already, then please let us know. We can look at trying to get a session set up around that in the future as well. So I'll leave it just to say thank you to Richard for the time today and for the great presentation, and to Marco for helping out on the Q&A as well. Anything from you guys before we close?
That's it. I'm just really excited to see what people want to do with it. Thank you for joining.
Yeah, and I'm really happy about this library. I think it's going to be one of the libraries that becomes like a classic as in the product or around the product. As Stephen mentioned, feel free to send question, answer, suggestions or requests around future planning. This is the beginning. It's not like, hey, we have a finished product. This is a preview, and there are plans to extend it over the entire next year. And but of course, we can certainly, tweak and modify some of the plans according to requests that are coming from people who start using the library and play with it. And again, they trying to get the download available and get it today. And yeah, I'll have a blog post about it when it's done.
Yeah, that's one of the great things about having Get It now, is being able to kind of iterate the updates as they become available and make them available for you. And you'll see in the IDE a note to say that there's updates available as well.
And the plan is every few months to get updates to the library. When new things are ready, without a strict timeline. So expect, keep following in, expect things to come. And as Stephen was mentioned, we'll do follow-up webinars on new APIs, or also, delving deeper into some of these technologies that were already presented today. Okay, and thanks a lot for joining the event.
Cheers, everyone. Thank you. Happy coding. Goodbye.
Thank you.
Bye-bye.